Hello, here we are back in the camper, ready to talk about adding and subtracting polynomials today. Now, this lesson will be a bit of fresh air because I know the last couple have been kind of a lot to digest, and this is just combining like terms. You have been doing this for years, since like 6th grade is when this first starts showing up in standards. So, I think that you will be quite relieved for a little bit of a break in the rigor that we've been having here. So, but it's still an Algebra 2 standard, so we're doing it. As I look at this problem here, which I'm going to work some out with you, so I would encourage you to write them down and do them along with me. As I look at these polynomials, I'm looking for like terms. So that means they need to have matching letters and matching exponents, basically. And I personally always look for the highest exponent first and then work my way down. So when I'm looking at number 3 here, I see this, this negative 9x to the 7th. Notice I said the negative with it. The sign always goes with what follows it. So if you are not good at seeing those together, you can always change the subtraction sign to adding the opposite so that you move the negative sign like right there with the negative, or as a negative 9x to the 7th. So negative 9x to the 7th. That's the only one that I see. So I'm just writing that one down. Also notice I underlined it as I counted it because one thing that's easy to do is overlook a term in these, and if you mark them as you go, if everything is marked at the end, you know that you didn't overlook anything. So let's see, the next biggest exponent that I see is I have some x to the 4ths up here. I have 17 of them. Do I have any other x to the 4ths? Doesn't look like it, so I'm going to put plus 17x to the 4th. I know it's plus because that 17 didn't have a sign in front of it, so we understand that to be positive. If I look for x cubes, okay, so here we have a couple of them. Here I see negative 2x cubes, and then I see plus 11x cubes. So if I put those together, I'm going to have 9x cubes, positive 9x cubes. So I'm counting up how many x cubes I have. Then if I look at my x squareds, let's see, here's 8x squareds minus 8x squared, so they're gone. I don't have to write down any x squareds because they vanished. And then if I look at my constants, it looks like I have a plus 4 and a plus 12, so that gives me plus 16 if I put those together. So there we go. We've added those polynomials together. Another one real quick. Let's see if I look through this. Highest exponent I see is the 11 right here, so 3x to the 11th. That's the only one of those I see. Next highest one I see is the x to the 6th. That's the only one of those I see, so I write that one down, plus x to the 6th. Then I see this x to the 4th, and that's the only one of those I see. Goodness, so not a lot is simplifying here. Okay, so now we have some we can simplify, because here are some x's. I have negative 8x's and then negative 1x here. So that's like an understood 1 coefficient. So that would make negative 9x's when you put those together. And then the last thing I have is that 17. So I'll put a plus 17 on the end. Everything's marked with underlines, so I know I got all of the terms. I didn't accidentally leave one off. So there we go. We've added those polynomials together. So we can also do subtraction with polynomials. So we're going to look at some examples here. So if you look at number 6, this subtraction problem, the thing about subtraction is you're not just subtracting the negative 9x to the 4th. You're subtracting all of that. That whole polynomial follows that subtraction sign. All of it gets subtracted. So you can kind of think of it like the distributive property. You can think of putting a 1 here and distributing the negative 1. That works. I like to think of it as adding the opposite. So here's what I typically do. I go subtraction. I'm going to change that to adding the opposite, the opposite, the opposite. So it changes all of the signs in that next polynomial because all of them are getting subtracted. So that negative applies to all of it. It's the distributive property. I took that negative sign and I passed it out is what I did there. Once you've done that, then it's just an adding problem like we just did a minute ago. So I look for some exponents. Highest one I see is the x to the 7th. and I only see that one term there with that, so 23x to the 7th. As I scan, I see some x to the 4ths, so here are negative 9x to the 4ths, and then this is now plus 9x to the 4ths because of the sign change that happened, so those cancel each other out, so they're gone. I don't have to write down anything for the x to the 4ths. Let's see, I see some x squareds here, and that's the only term that has x squared, so I'll just write those down. Notice it's negative now. And then as far as the constants, I have this plus 31 and this plus 1, so that makes plus 32. So there we go. That's what you get when you've subtracted those polynomials. Let's try that in number 7 down here. So I'm going to take my negative sign, the subtraction, and then I'm going to change it to adding the opposite. So I'm distributing that negative. Then let's see. I see some x to the 5ths. So if I put the negative 8x to the 5th and the plus 2x to the 5th together, that would be negative 6x to the 5ths. We're counting up how many x to the 5ths we have. I don't see any x to the 4ths, but I do see some x cubes. Here's some x cubes. Looks like that's the only one. So 7x cubes. I see some x squared, so let's deal with those. So here are 20x squareds. And then here's minus 9x squareds because that negative sign there. So that would be 11x squareds. There are more positives than negatives there when I'm counting those x squared, so it's a plus 11x squared. And then it looks like I have that 13x. And that is everything because all of my terms are marked with underlines, so I know I didn't forget anything. So there's that. Now here's where you would use something like this. I have a story problem here to show you. Let me not go too high so you can read it. According to the data from the U.S. Census Bureau from 1990 to 2009, the number of commercially owned automobiles in the United States can be modeled by the function a of x equals blah 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 polynomial, where x is the number of years after 1990 and a of x is the number of automobiles in thousands. So a of x is commercially owned automobiles, okay? The number of privately owned automobiles in the United States can be modeled by the function p of x equals blah 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 polynomial, where x is the number of years after 1990 still, okay, so that's the same. We're tracking from 1990, and p of x is the number of automobiles in thousands. So p of x is the privately owned automobile. So you have a of x for the commercial ones. I don't know why they didn't use C there for commercial, but whatever, they didn't ask me. So A of X for commercially owned automobiles, P of X for privately owned automobiles. Now for the question part. It says estimate the total number of automobiles owned in 2005. Total. How do you find a total? Total means you add. So what we can do is we can add these polynomials together first to get one function for the total, and then to figure out how many were owned in 2005. Okay, so we're keeping track of x as the years after 1990. So how many years after 1990 is 2005? Well, let's see. It takes 10 years to get to the year 2000, so another 5 years to get to 2005, so we're talking 15 years. So you would plug in a 15 for your x. You honestly could plug the 15 in for the x right now, the way the problem is written, into the a of x function and into the p of x function, but it would be much easier calculations if you combine those first into one polynomial. It'd be way less typing in your calculator, and the less typing in your calculator, the less room there is to make a mistake by hitting a wrong button. So I would recommend adding those together first. Well, I think that is everything that you need to be refreshed on for adding and subtracting polynomials. So remember that Jesus loves you and so do I, so do your math.